Hello everyone, welcome to Tech on Cloud. This is your host Abhishek Kushwaha back with another interesting video on this Golang series, which is concurrency in Golang. So first of all, what is concurrency? Concurrency is the ability for functions to run independently of each other. Means any other functions or methods in Golang which run independently can be said that it has concurrent feature. Okay, so as we are talking about concurrency, there comes a similar relative word which is parallelism. So let me clear what are the difference between concurrency and parallelism. In concurrency, it is all about dealing with lots of things at the once. Okay, and in parallelism, it is about doing lot of things at once. Okay, so if you go with the definition, concurrency states that ability for functions to run independently of each other, as I said in the starting. And about parallelism is a runtime property where two or more tasks are being executed simultaneously. Okay, so let's move to the another slide and see what are the methods through which we can achieve concurrency in Golang. So we can basically achieve concurrency using 5 methods or mechanisms that are, first of all, Goroutines. Okay, then making use of select statement, then using multiple Goroutines in the program, then in the fourth section making use of the channels which are the communication medium for the Goroutines, and last one is unidirectional channel. Okay, so in this video we would be covering about Goroutines. So let's move to the next slide. So what are Goroutines? A Goroutine is a function or method which executes independently in connection with any other Goroutines present in your program. Or we can say that any independently occurring activity in Golang can be considered as a Goroutine. Okay, then Goroutines act as a lightweight thread. So if we modify this, we can say that Goroutine act as a lightweight process. Okay, then the cost of creating Goroutine is very small as compared to thread. We would be observing this as we would be going through some examples. Okay, let's move further and try to see what are the syntax of using Goroutine. So you can see on the screen in the slide it says function name is a normal function which includes statements, and then we as a comment there is written that use go keyword as a prefix while calling the functions. That means as the definition says, the function or a method which executes independently. Okay, that means we declare the name of the function in the starting and we call it using a go keyword as a prefix to make it a Goroutine. So any function which would be called using go keyword would be considered as a Goroutine. Okay, let's further to the VS Code section and see how this Goroutine works in a program. Okay, so I am switching to VS Code, and here you can see I have file name goroutines.go open. Okay, so to illustrate the concept of Goroutine, let's write a program. So I would be using one simple function call and one Goroutine function call, and first let's observe what is the difference. So the first one we would start with package main, and let's import fmt, the basic structure of the Golang program, as I told in previous lectures. Let's first write that out. Func main, and then curly braces. This is the basic structure. Now let's make a normal function. If you remember the syntax, what it says. So func display, then let's take a string of variable str and string, then open curly braces. Let's take a loop. Now loop will be going for a variable which is shorthand declared, and we would be encountering it to less than 6. Then let's increase the value of w and open curly braces again, and let's print it out using fmt.println str. Okay, so this is the normal function to print a string. You can say 6 times. Okay, now let's call it in the normal way. Display, then say welcome. Okay, now let's make another function call with the go as a prefix. So go display, and let's make slight difference, use smaller welcome. Okay, and let's try to find out whether our all these things goes well. That means both the function calls for 11 and 12 are called. Okay, let's verify it once. Control S, I saved it. Now let's run it. Go run goroutines.go. Okay, main is undeclared, it says. Oh, my function main, the spelling of main is wrong, sorry guys. I will correct it out. See, so what is happening, we are getting only the normal function call answer, that is display capital W welcome is repeating 6 times according to the loop for the function display. So what is happening here? So we first create a display function, then call this function in 2 different ways. First one is using a go routine, which is go display capital small welcome, and another one is the normal function that is display and where W is capital. Okay, but in this program there is a problem. As you can see, we are getting only the normal function call. Is it so? Because it only displays the result of the normal function, that does not display the result of go routine. Because when the go routine executed, the routine call is returned immediately. That means when the pointer comes to the line number 11, it goes back straight away to the line number 12 without allowing it to print the result. Okay, so the control does not wait for go routine to complete their execution, just like normal function. They always move forward to the next line after the go routine call and ignores the value returned by the go routine. As we can see in the program, it is currently happening. So to make this program work properly, we have to make some changes in the current program. So what we will be doing? So we would be adding one sleep method in our program, which will make the go routines sleep for 1 second in between. Okay, so when this main go routine will sleep for 1 second, this our main this go routine, which is go display small welcome on the screen, will be executed in that 1 minute of sleep. Okay, Let's do the practical and see the observations. So I would be putting this leave function here, not this will be going there. So bracket close, tab, then we will be sleep, using the sleep, not sleep, it's time. Sleep would be the function. Okay, tab, yeah, let's say time dot sleep. We would be calling sleep method from the time package, and we'll be trying to make it sleep this function for 1 into time dot second. So it will be sleeping from 1 second, that is 6 seconds according to this loop. Okay, I hope you all are understanding this, whoever is watching this video right now. So if you had any question, just comment it out in the comment box, and I will be trying to answer to you by explaining more clearly. Okay, so I have implemented this sleep method. Okay, so let me make it more clear. This is our Goroutine operation. Okay, and this is the normal function operation. Okay, let's save it, run it, time dot sleep. Okay, SS should be capital, we are calling it. Okay, save. Now let's run it. Okay, as you can see in the output, it is saying take on. There is both the output. It may not be clear like this way, so let me change the function call here. For this Goroutine operation, I would be printing check on cloud. Okay, so that difference is visible. Let's save it, clear it, and run it. Let's see. As you can see, the thing, both the functions are being displayed. Both Goroutine operations and normal function operations, both are displayed, but at the regular interval of time. So this is because we added sleep method in our program. Okay, which is making the Goroutine function to sleep for 1 second, and in between that 1 second new Goroutine executes and displays the welcome on the screen, and then terminates after 1 second. Main Goroutine is rescheduled then. Okay, so this process is continued until the value is z less than 6. After that, main Goroutines terminates, and as you can see, both the outputs are displayed concurrently. Okay, so this is how Goroutines work. Okay, now let's move back to the slides and try to understand some advantages for Goroutines. So let's go to the next slide. So as you can see in the first point, they are cheaper than threads. Okay, so they are basically less occupational, or we can say that it takes very less time than a process to execute a Goroutine. Okay, and Goroutine communicate through channel. So spelling of through is wrong, yeah, through channel, so due to which they prevent race condition. So I hope all would be knowing what is race condition if they have gone through the operating systems, they must be knowing. So, and the other advantage is that if you are having a program and it has one thread, means one process, then the and it is that one process is associated to many Goroutines, That means one process and many goroutines for that one process. Okay, and if any of the goroutine blocks the thread due to the resource requirement, then all the remaining goroutines will be assigned to the newly created OS thread, which would not be objecting your execution of the program, and it would be executing smoothly. Okay, so these are some advantages of goroutines in Golang. So this is all about goroutines. In the next video, I would be talking about the second method, which is select statement. So there would be 5 series for concurrency part in this Golang. There will be 5 parts for concurrency in this Golang series. So second would be select statement. So stay tuned for the next video. Okay, so let's come to the next slide. Yeah, so this is all about goroutines. So the one method for concurrency, that is goroutine, is done in this video. Next would be select statement, and it would be coming up very shortly. Then if you like this content and tutorial, please do like, share, subscribe this channel, and don't forget to hit the bell icon to get the latest notifications on the videos coming up on this channel. And yes, if you have any doubts, do reach me out on my GitHub profile, LinkedIn profile, and Gmail. Okay, and I would be trying to upload these documents and all the programs on my GitHub profile, so that whoever is interested in looking and gathering knowledge can see this one. Till then, see you in the next video. Thank you guys. Bye bye. Take care.